What is up, girl boss? Let's talk about maxes and mins. Can you point them out on this little graph here? Well, there's two different types of max and mins. There's absolute max and mins and then local max and mins for some local flavor, some local fun. Let's start with the easy stuff, the absolute max and mins. This just means what is the highest point on this graph? And the min, absolute min, is what is the lowest point on this graph. So it's pretty easy to see that this point down here is going to be the absolute min because it's the lowest. Similarly, the absolute max is up here. Okay, so you're not stupid. That's pretty self-explanatory. But what are local max and mins? Well, see how this graph is curvy? She's a curvy girl. She's got some curves going on. See these points at the end of the curves? Oh my god, they look like nipples. No, wait, fuck, okay, but see these curves here. See these dots at the points of all of these curves? These are going to be a max or a min, and then within that they're going to be either absolute or local. So absolute, we've already talked about, is when they're the absolute biggest or the absolute smallest. The max and mins here are if it's facing this way, this point right here is going to be a minimum, and if it's pointing this way, this point is going to be a maximum. But because they're not the biggest numbers, they're going to be local mins and local maxes. But how are we supposed to know what's the local max and local min if they just give you a function like this? Okay, so let's say your teacher gives you this function and they're like, okay, bestie, what are the
local max, local mins, critical points, absolute max, absolute mins
from 5 to -5. Okay, your first step is to take a derivative of a function. Just trust me on this. I'll explain why later. You're going to take its derivative, so that's going to be x squared plus x minus 6. Okay, next step is to set it equal to 0. So we're going to set this equal to 0, and then we're going to solve. So this can be factored into this problem, which makes our x's that give us 0, -3, and 2. These are the critical points of this function here. The critical points determine where your maxes and your mins of the function are going to be. So we already know there's going to be either a local max, absolute min, whatever you may have it at -3, and there's also going to be another one at 2. We just don't know which ones yet. So to find out what it's going to be, we have to draw a number line and plug and chug. Yeah! So here's our number line. And now we have to write our critical points on the number line. Cool. Our next step is to plug numbers in between these little sections here into the derivative function to see if they're positive or negative. So let's start from over here. So let's say 3. If we plug in 3 into here, we don't even care about what number it's going to give us. We just care if it's positive or negative. So that's going to be positive. What if we plug it into here? This one's also going to be positive. So it's going to be a positive times a positive, which is a positive. So we know that in here it's going to be positive. Okay, now in the middle, let's pick the number 0. So if we plug 0 into here, this is going to be a positive number, and this is going to be -2, negative. A positive times a negative is going to be a negative. Now, if we plug in a number on this side, let's pick -4. If we plug in -4 to these two things right here, this is going to be negative, and this is also going to be negative. So a negative times a negative is a positive. Okay, so here's where things get a little bit conceptual. Okay. This is dealing with the derivative. We have a positive derivative here and negative derivative here. What the fuck is a derivative? A derivative means slope. So you can think of a positive slope looking like this, right? And a negative slope looking like this. We know that these points is either going to be there's going to be a maximum or a minimum of some kind. So this is what I like to do. We know that it's slope, so I like to draw it out a little bit. So this is a positive slope here. So it's positive, 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 positive until it gets here, and then it's negative slope. Then it's positive again. So we can tell that this is a max and this is a min just by kind of looking at what the slopes are telling us. We don't know if it's local or absolute yet, but we can know that it's a max or a min. Pretty cool, huh? Next step is to plug in the endpoints. Remember, don't forget about these, the endpoints and the critical points into the OG function, meaning this function, not this function like we did before, meaning the OG function, so that we can find the values that all of these little points give us and see which one's the highest and which one's the lowest, so we can figure out what's absolute and what is local. So if we use a calculator, we can kind of see the answers here. This is the graph of this original function here. So if we just compare these numbers right here, we can tell that this is obviously the highest and this is the lowest. So we know that f is 5. This is going to be our absolute max because it's the biggest one. It's going to be right here. That makes sense. It's the highest one. The smallest one is going to be at f is equal to 2 right here, which makes sense. We can see it on the graph right here at the lowest point. So this is going to be our absolute minimum. Now, this one here, it's still a max, right? It's still a max because it was one of our critical points. But it's not going to be the absolute max because that spot's already taken. So f at -3 is going to be a local maximum. And then this one you don't have to worry about because it's not a critical point and it wasn't your absolute max or absolute min, so you don't need to worry about it. So your answer for this one would be this.
Okay, love you. Bye.